Velkommen til LØRN.tech, en læringsdugnad om teknologi og samfunn, med Silvija og venner.
Hello and welcome to lecture 2 on AI by one of our masters of AI, Morten Goodwin. This second lecture will be about a conversation about examples, your favorite examples, Morten. Which examples of AI do you think will help people understand the topic? So where do you want to start?
Well, we can start in many places, I think, but I suggest we start with game playing. That is one of the areas where artificial intelligence has really mastered the world these last years. And it was one of the big challenges in the beginning, playing chess, playing checkers, but the researchers, John McCarthy and others, soon realized how complex these games were, that it was tremendously challenging to make an autonomous way to solve it. We touched slightly upon it in the first lecture, but I think key to it is this IBM system that was in the 90s, where we had a search mechanism, and then DeepMind's Alpha series, starting with AlphaGo and then AlphaZero in 2017, 2018, etc. And the reason games are so important is that it is a very controlled environment. We can see exactly everything that happens in a game. We can understand the rules of the game as humans, and also the computer program, the AI, can also understand similarly. So it's not so messy as the real world in a way. It's not as messy as the medical world or driving world, etc. That means that we have tremendous control over the system. As we mentioned in the first lecture, we had a system where it first trained from human examples, and then it went on and trained without human examples, and it became even better. So meaning that the data that we gave in as humans became an obstacle. We humans did not play Go, in this case, good enough to train an AI. So when we removed humans completely, it became much, much, much better. And that's a good lesson learned, because data is absolutely important. In this case, it turned to be the actual obstacle of the system.
I just want to interrupt for a second, because it makes me smile on how interesting philosophically it is as well. Mm-hmm. You know, we see that with the self-driving cars as well, or autonomous cars. Yep. Human is the last bug in the system. Absolutely. But is it, we don't want a system that is perfected and where humans are made completely irrelevant. So I guess this idea of finding the place for humans mm-hmm. is a very, very important ethical area of yep. AI research, and we'll get back to that on sure. what's human, what's machine.
But I think we can already bring the human in here, because grandmaster players such as Magnus Carlsen, they use these AI systems to train themselves. So the circle has been completed in a way. So instead of the masters giving chess examples to the chess computer now gives examples back to the human, because we want human in the loop in those areas. And in many other places we want it. Yes, what do you think, Silvija?
No, I just can't stop being philosophical here, and I promise I'll stop after this sentence. But I think it's a really important point. So this is making them better. This mm-hmm. is making their chess playing more interesting, more efficient, more fun. And I think what's really important here is that we have found a way to use the technology so it makes not just the world more efficient, but it's making our lives better. And I think mm-hmm. it's a really important part of what we should be thinking about is, how do these self-driving cars not just yep. make more money or, mm-hmm. but how do they make life and the world better in terms of fewer accidents, better climate. So we are not. Sometimes I feel that people believe that AI will remove humans from the loop, and then we've solved all the problems. And if we do that, then I think we've actually made a much bigger problem.
Yeah, that's right. Self-driving car is a tremendously interesting example, because it kind of touches upon many of the areas of artificial intelligence at the same time. So it has image recognition from these LiDAR scanners, which has, I don't know how many, but a lot of pictures at the same time in 3D. It's complex to see, and it has to make decisions all the time. Should I turn left or right? But when should I brake? What should my speed be? So it's a very, very complex problem. And I'm sure you're aware of this DARPA challenge that came from some time back. It's been a challenge that is essentially, can you make a self-driving car in some way? And I'm not sure I remember the details of the story, but at least for a long time, they used traditional techniques. It takes a long, long time to learn and makes bad mistakes. It separated whenever a bush came in the way, it went the wrong way, these type of things. But a couple of years ago, it really, really became much better. And the reason is, of course, they put deep learning on the topic. And deep learning is just an AI system that is used for chess playing, image recognition, and a lot of other areas, and also self-driving cars. And then it's very apparent. These type of games, you can say, chess playing, may be very important for Magnus Carlsen, etc. But the application area, if you ever drive a car, or if you ever in traffic, or if you ever walk outside of traffic, it matters for you. and then of course it does. Environmentally, absolutely, because we want to drive more efficiently. We want to have fewer cars because production of cars is also environmentally costly. And we want to share car rides. So if you look a little bit into the future, I think the idea of everyone owning a car or even two cars, as we do and live far on the countryside, we have to have two cars. It's like a stupid way of thinking. We can all share, but AI is essentially to be part of that, because
here you also exemplify an area where people need to make political decisions related to technology development. So I know lots of people who say, well, I like driving. I don't want to be replaced by an algorithm. And then, and so some people's paradise is other people's hell. And so is it always. So this is where majority has to decide, do you want more safety, or do you want people to decide if they want to drive themselves or not? And these are kind of political democratic negotiations, but we need to educate the people that this is a sort of a problem you're going to have an opinion on relatively soon.
Truly, I fully agree. And you can take that example even further. So there's even people who like to ride horses. Before, everybody was riding a horse, but nobody would say we should only have horses in our streets anymore, because that's ridiculous. But there are still places where people can ride horses, and of course, please go ahead. And I think for driving, it will be the same. Some people like to drive. I'm not one of them. I'm not particularly good at driving even, but I have to. Every day I almost drive somewhere, mostly to my job. And I would much more spend time reading or doing something else, right? And that is the key, because we want to automate those part of the world that we don't really want to spend our time doing. And then that is why the AI revolution is so important, because we see that as a potential many places. Game playing, true. Self-driving, absolutely true. And then we see the same in medicine, where you kind of play games with antibiotic material, for example. And then I think a bit more than a year ago, a bit before COVID, we found a new antibiotic material that needs to be tested in real clinical tests, etc. But it gives the potential of what AI can really do with these game playing systems.
I want to go back to that idea of AI in health. So let's hold that thought, because what I want you is to talk a little bit about it, but also think about the same ethical question we talked about now. So if much more of the job of the doctors and of the nurses and the other staff will be done in some level of AI and automation. On one hand, we are dependent on it, because that will actually make more health services accessible to all, to all. But at the same time, can people then say, sorry, no, I want the person. I want the person to diagnose me, not the machine. Or I think this will be really interesting. Yeah. Before we go there, and before I lose the other thread I have, we started with games, and you mentioned AlphaGo, AlphaZero, and MuZero.
MuZero,
I don't know about that one. So would you please just help us understand the three?
Yeah, so AlphaGo was the first one that played from Go games, and it was very limited to playing this only one game, Go. You could not play anything else. And then
Chinese
Old Chinese, it's kind of similar to Othello. Maybe some more people have heard of it. You play black and white pieces, and you're supposed to capture the white if you're black, and if you capture the black if you're white. So you can compare it to chess because it's the same line of thought, but it's bigger, more complex, and it is older than chess. So a chess player would say that, a Go player would say that chess is messy and new and fancy. We want to play this old-fashioned game because that's kind of the game of the gods, I think. So it's a very complex game, and when David Silver solved it, meaning that AI was able to play better than the best human in 2007, it was really a revolution. But that was AlphaGo. One of the criticisms was that, it's very limited to only playing Go. So then and it's very limited based on data. So then he did two things more or less at the same time. He removed the data, meaning that they could play only with itself. And then he made it applicable to both Go, chess, and shogi. Shogi is like a Chinese version of chess, meaning that you play the board, and then when you go to the next other side of the board, you kind of flip back a bit. So it's similar, but different. And then he showed that the same technique with minor differences could solve all three at the same time. So it's kind of generalizing it a bit. Truly, truly amazing. There's still a big limitation to all of those, and this is that you have to write the rules of the game. You have to say that the rook moves in this way, the knight moves in this way. So for chess and Go, not really a big problem. But for real-world examples, self-driving cars, etc., it's a big problem because the rules of driving immensely complex. So it's not like human level, but like for a computer, immensely complex. And then mu0 is the next level after alpha 0. And that you don't even include the rules. So they should learn the rules by themselves by the game. You just interact and say, this, you didn't win, you lost. So it kind of iteratively learns also the rules of the game. And it turns out that when you do that, not even is it possible, but it plays even better than when you add the rules. So the rules themselves are kind of a limitation. And that the key is that this opens for much, much more application areas. And then he didn't do only those three games. He went back to Atari, meaning that he could play all of those Atari games, not adding the rules of any of them. Just please learn the rules. Please learn how to win. And the assumption is then, please, you can do that in real life world, medicine, finance, etc., without adding the rules there.
So if I try to simplify, mu0 sort of algorithms applied to health could then diagnose a cancer without having been told that this is the patterns you're looking for, this is the color, this is the type, the shape, the whatever. They can figure out they can figure out what the game is, what I'm really looking for.
Exactly, yeah. So I think the patterns themselves, they kind of figure out anyway, but it's more that what affects a certain system. So when you do diagnosis, you typically do it in what we call the supervised way, meaning that there's one correct example. But sometimes you would say that maybe this medicine affects the patient differently than this patient, for example. So those kind of rules, which is very closely related to individualized medicine, which we think is the future of medicine. So I'm different than you, and then I should have different medicine than you if I'm sick for some reason. And it is more those type of application areas that mu0 potentially can be useful for, because the human body is a complex game, you could say, with complex rules, and the rules for you and me are very different because we're different people. So that is the
cool. So finding the critical rules or understanding what really matters, and now we are approaching the question of, do they really understand what they're doing or not? And they can be very efficient. Sure. They still don't know what the real drivers are for us humans, needing them to solve that problem necessarily.
Absolutely. And they also yeah, please, Silvija.
Sorry, go ahead.
No, they also played some other games, which are, I think, very fascinating, because they played poker and a game called Hanabi. And the key to those games, so it was not DeepMind who played poker, it was another research group, but the same type of technology, because that is a very much more human game to think of. So chess, you can think of almost as a mathematical problem to solve. It's like you just have to find the correct piece. But when I play poker or Hanabi, which is quite similar, at least the way of thinking, it is have to understand why are you bidding so much? Is it because you have good cards, or is it because you're lying to me? And kind of putting that type of human knowledge, can it understand what I understand? So as a human, I have what is called theory of mind. It means that I understand myself, to some level at least, and I can also put my mind into your mind. So why are you saying what you're saying now? And the chess world, it's not so important, but in Hanabi, this kind of card playing game, it's much, much more important. It's the essence of the game. So what does it understand? At least it understands at the level that it can find a pattern, because that's still what it does. But it kind of can put its mind, in quotation mark, into other people's mind, also in quotation mark, and then play accordingly. And that's important because that's what medical doctors do, for example. So why are you saying that you have a bad knee? So maybe it's your bad knee, but maybe it's because you went running last week, or that's like essentially human to do that. So yeah.
So this human understanding, finding again patterns in our behavior and in our psychology, I think will be a super important and very interesting part of applying AI to social problems. And again, the question is, in how large extent do we want the computer to tell us, and in how large extent is this actually the core of our politics?
Yeah, yes, I think the different levels there, but I think AI and other advanced digital technology will play a more and more important role in the political part and the societal part of problem solving. I don't think it will be the only thing, because it should be decision-based supports. So meaning that if a politician should make a choice, so typically what happens today is that they ask some experts to, in Norwegian it's called utredning. It's like some sort of survey about how things what will the effect of changing the education system in this way, for example. Some expert needs to find it out. And in this case, AI could play a significant role, saying that if you change it this way, this may be the effect. If you change it this way, it may be an effect. And then in the end, it's like a political and in a way ethical way. I think it's more important that business thrive. I think it's more important that everybody has a good healthcare system. So that's kind of like the human ethical decisions, and those elements AI is not so good at.
So if I'm rephrasing what I hear from you, it is a human-only responsibility to be asking the right questions. And then the computers can be an immensely useful analytical tool. They can show you scenarios. They can compute many different results. And then it's still a human decision to kind of make those based on different priorities. These are often multidimensional problems.
Yes. Choose
the right solutions.
I think, and then you can look at the recent example of COVID as one. So whether or not to shut down, it has to be a political decision. But the potential spread of the disease, the potential impact of shutting down, the potential impact of not shutting down, the potential impact of sending vaccines to Oslo versus another area, for example, could and to some extent are AI-based solutions. But in the end, there has to be some political, at least political-like system that makes the decision, because it's such a human way of thinking.
Yeah. So I think actually we in many ways answered my question about healthcare AI and ethics, or the social side of it. Basically, we will want people in roles that require you to have, this human understanding of relations, of history, of politics. And it's messy, but it's uniquely human, and then we can't leave that to the machines. But we want to use the machines as really great tools. I want to ask you, we have about 10 more minutes in this lecture, and I'd like us to talk a little bit about. You said chatbots, and you said protein folding, and I would like to ask you about a very recent and relevant example on Corona or COVID. Vaccination, or where was AI useful in the pandemics and where it wasn't? I don't know. Where do you want to start?
Yeah, so let's start from at the end. I think so. AI wasn't used that much in COVID. It was other techniques mostly, but there is absolutely examples of COVID-based AI, and that is for prediction of disease, for example, through social media or through other area. And it is a prediction of where there will be future breakouts and even but even more importantly, I think, because those systems also can be used without AI, is kind of resource allocation-based methods. I don't think in Norway it was used at all, I would say, but what you can do and what was used is that you can say that there's a need for a system to send vaccines in this area because of some logistical issue. It will take longer time than in this area, etc. And it's been projects on that, even at my university, to kind of make this more efficiently in a way. It tells you the potential for AI there, but it also tells you a bit of the limitation, because in the end, mostly this was a human-based approach, because we want control. We want to be completely 100% sure that this works perfectly. And also there's, fortunately, I would say, not many examples of pandemics in recent history that can be used as an input to training those type of systems. So let's say COVID-25 or COVID-29 may be more applicable to have more AI as useful, because it's like the third or fourth example of it. And then we can go track back. AlphaFold, it kind of pushes the same boundaries as game playing, because it's very, very similar technique. It's not AlphaZero for game playing, but it's AlphaFold for protein folding. So protein folding, as probably some of your listeners know, is that you have some sort of proteins in your body, and when you just stretch out a protein, it folds in some certain way. And how it folds and the final structure, so biologists and people with medical experience can tell what the protein does. So does it bind to this molecule and then this medicine will work, or does it bind to this molecule and it will this type of side effect? But giving the set of protein, which is often known of a medicine, for example, and it's the way it folds, is a big problem, and has been for many years. And then there's this big competition that happens every second year. Can you use AI or any other technique you like? But recent years, people are using AI to predict these type of folding systems. And then DeepMind, again, one of the big tech companies in the world here, Google DeepMind, they were able to more or less solve this type of protein folding system. And that means that you can give it a protein, it can tell you how it folds. And just a couple of weeks ago, they released that it released a public article on that, and even open source code doing exactly the same. So we were a bit skeptical. Would this very, very important technology be owned by Google and only Google, or will it be given openly? And in the end, they gave it openly available out. And Nature, this journal, most famous journal, I think, said that this will change everything. This is the most important scientific discovery last 10 years. And they think, or they philosophized, I guess, they speculated that it will be the future of medicine in a couple of years. It will be the future of reducing plastic waste, because you can specify proteins to chew, I guess, plastic in some sort of way. And also environmental problems. You can bind proteins to specific carbons, and it kind of solves part of it. Key to it is learned from an AI system, and it just gives you the potential of this type of revolutionary technique. Where you think AI is limited to Go and chess, etc., turns out just apply it to any other area. A lot of human intelligence, of course, but a lot of artificial intelligence also, and then you have yourself the next revolution, which is what happened there.
So we'll go back to chatbots as well for just a couple of minutes, but I have to put two remarks here, Morten. So one of my favorite books, as I mentioned to you before, is one called Deep Learning Revolution by a guy called Teres Sejnovsky, who's in my mind one of the fathers of this area, and I adore him and I adore the book. And the other book that I'm thinking about now that I really enjoyed is a book called The American Prometheus. And it has nothing to do with AI. It's about Oppenheimer and the making of the atomic bomb.
Oh, right. Yeah,
and of course, it refers to the Prometheus, who was punished by the gods for giving fire to people. forever having, I think, ravens or eagles eating his liver or something terrible like that.
That sounds terrible, yeah.
But sometimes I wonder, and the American Prometheus refers to Oppenheimer as, giving this immensely powerful weapon and tool to the humanity. And I think he had this comment when he saw the first successful testing of the hydrogen bomb in, I think, Los Alamos and thus he regretted apparently and was saying, and thus I've become Shiva, the destroyer of worlds. And, I wonder if these fathers of AI ever have thoughts like that, because when you talk about this incredibly useful, necessary, proteins folded specifically to eat all the plastic, or, kill certain kinds of bacteria, attack certain kinds of virus. I mean, these things can easily either go wild. There is this exponential effect of everything data-driven, right? Or they can simply be used by people who are not suited for tools that are so globally powerful.
No, it is a dilemma, and it's a well-known dilemma in technology. It's often referred to as Collingridge dilemma, and that is you want to have. It's very hard to understand the effects of technology before it's put in place. So if you want to do regulation of technology, for example, that is practically impossible before you've seen the effects of the technology. Atomic bomb, AI, what put you? But at the end, when you see the effects, then it's too hard. Then it's too challenging to stop it because it's already put in place. So hydrogen bomb, for example, it's after it was invented, very hard to regulate. Same with AI. After protein folding is there, it's such a powerful technique to use for good, making medicine, bad, using artificial viruses that we send out if we want to, but you can. So you're kind of you could say that the AI founders are Shivas as well, the destroyer if they want, but they're also the builders and the creators. And we should not, at least, at the very least, not stop creation because the potential of bad is there. Because then we can just say, let's not do technology advancement at all. But when we see problems, there needs to be regulation, absolutely. Either from nationally or internationally. I know EU has a suggestion for a regulation that came a couple of months ago on AI, and they do something that I think is very smart. They look at the effects only, not on the technology. They don't say that don't use deep learning or don't use statistical techniques in this area. They say that if you're in a system that has high risk, such as medical diagnosis, you should have put particular importance on explaining why such a system makes a decision, for example. And if you the low risk, such as a game playing system, it's not so important. You can make a AI that is the bad person in games. That's fine. And if you do such things as surveillance, that should be only from a police or governmental agency that controls it. So meaning that you have this type of risk levels, as they say, and this type of ways to regulating it. And it all is about what is the effect for people who are using it in some sort of way. And I think this is a very smart way of thinking, because you don't limit yourself to the technology today because it's so fast, fastly changing and rapidly becoming better and worse if you use it for bad things. But at the same time, it is something that we need to explore. We need to understand. Is it like an atomic bomb that destroys us? Hopefully not, but it potentially can. So we need to be careful. But the important thing is that technology makes our lives better in so many ways. So we should be positive, I think.
I completely agree. I think that it's necessary, and you it's a Pandora's box. You can't close it. Yeah. And if one person doesn't invent it, another one will. I think it has a force of its own.
That's true.
But it's necessary for us to think about the future in an optimistic and loving way, as wishy-washy as it sounds. And it's necessary for us to learn about this technology. Otherwise, we can't have any opinions about what's good, what's bad, right? Or it'll be opinions that are irrelevant. So it's all about educating the people.
Yes, which is why we have this masterclass, isn't it? So that's true.
Exactly. Listen, Morten, we are going to finish lecture 2 now.
Okay.
And maybe we'll save a little bit on the next lecture just to tell people as we talk about the tools. Yep. And the tricks and tactics of this on how it's applied in chatbots. Does it sound okay?
Yeah, so you mean that we move the chatbots part to the next one? Yes.
Yes.
Yes, that's fine. We can talk about chatbots, absolutely. Yes.
Cool.
Du har nå lyttet til en podcast fra LØRN.tech, en læringsdugnad om teknologi og samfunn. Nå kan du også få et læringssertifikat for å lytte til denne podcasten på vårt online-universitet LØRN.university.